In this video, we are going to be writing chemical formula using the valency rules. Valency is used to write formula when there are no prefixes present in the compound name and no information available to us to let us know how many atoms of each element are present. The valency rules can also sometimes be called the crossover method, and there are 5 steps that you need to follow to work out formula correctly when using valency. Step 1. Write the symbol for the element. Step 2. Write down the valency. Now for the main group elements, remember that the valency is the number of unpaired outer electrons that the element has. For our transition metal elements, the valency is usually given as a Roman numeral. So I is 1, II 2, III 3, IV 4, V5, VI 6. If a Roman numeral is not given, assume that it is 2. Step 3 then is our swap step, where we swap our valencies over. Step 4 is our divide if possible step. And step 5 is when you write the formula together. And for shorthand, I write that as the SVSDF, or valency rules. So when you hear me saying this is what I'm talking about. Now let us work through some examples of that. So our first example is boron fluoride, and I would suggest that when you're working through these valency rules that you write out the compound name to begin with. I would also suggest that you write down the steps at the side. The symbol for boron is B. The symbol for fluorine is F. The valency for boron is in group 3. It has 3 unpaired outer electrons, so its valency is 3. Fluorine is in group 7. It has 7 outer electrons, however it only has 1 unpaired outer electron, so its valency is 1. We then swap these positions. We cannot divide these evenly by any number. We can divide them by 1, but there's not a point, it's the same thing, so we just score that out and ignore it. And then we write our top line and our bottom line. Now, as we have mentioned in previous videos, you do not need to put the number 1 in, because as soon as you have written the element symbol, that suggests that there is at least 1 atom present. So our formula is BF3. Let's move on and do the same for carbon sulfide. So again, I'm going to write symbol, valency, swap, divide and formula down the side and work through these steps one at a time. Carbon has the symbol C, sulfur symbol S. Carbon is in group 4, it has a valency of 4. Sulfur is in group 6 and it has a valency of 2. You then swap these round. Now this time you can divide here, so 2 divided by 2 gives you 1 and 4 divided by 2 gives you 2. So our formula is C1 S2, and we rewrite this as CS2. As you become more confident at working through these valency examples, you'll find that you don't need to do this step. Let's look at our third example, hydrogen iodide. Hydrogen has the symbol H, iodine symbol I. The valency of hydrogen is 1, and so is the valency of iodine. Swap those, can't divide them, and we write the formula as HI. Example 4, phosphorus chloride. Phosphorus has symbol P, chlorine has the symbol Cl. The valency for phosphorus is 3. It's in group 5, but it has 3 unpaired outer electrons. Chlorine's group 7, 1 unpaired outer electron. We swap these. We cannot divide them. And our final formula is PCl3. Now here we are going to start looking at our transition metal elements. And because they can have so many different valencies, we are usually given a Roman numeral that states the valency for us. If a Roman numeral isn't present, so if this just said tin chloride, we would assume that the valency is 2. Let's work our way through this one. So we've got tin chloride here, and again the very first step is just to put down symbol, valency, swap, divide and formula. The symbol for tin is Sn, and it has a valency of 4, so we can go ahead and put that number straight in. Chlorine, Cl, valency of 1. Swap them, cannot divide them, and when we write it as formula we have SnCl4. Make sure when you are writing element symbols that have 2 or 3 letters that your first letter is an obvious uppercase letter and the second and third letters are obvious lowercase letters. Moving on to example 7, lead bromide. Be careful that you're not caught out with your symbols here. Lead's element symbol is Pb, our valency is 2, bromine is Br, group 7, valency of 1. Cannot divide, so we have lead bromide. And our last example for this video, we're going to look at iron 3 sulfide. The symbol for iron is Fe, the symbol for sulfur is S. Here we are given the valency of an iron, it's 3, so we can put that in here. Sulfur is in group 6, it has a valency of 2. We swap these over. We cannot divide them. And so when we write our formula, it's Fe2S3.